Betelgeuse, a red giant star in the Orion constellation, has recently exhibited unusual changes in brightness, which may have significant implications. Astronomers have been uncertain about the cause of this brightening, but a team of researchers has now reinterpreted long-standing patterns in Betelgeuse's variability and reached a striking conclusion. According to their findings, the star is not only in the carbon-burning stage of its life, but it is also approaching the end of this phase. If their interpretation is correct, Betelgeuse could progress through subsequent stages relatively quickly and potentially explode within a few decades, meaning that the star might go kaboom in the lifetime of people reading this article. Traditionally, the prevailing view has been that Betelgeuse would not undergo a core collapse supernova for approximately 100,000 years, or possibly even a million years, as per astronomical timescales. However, a preprint study submitted to the monthly notices of the Royal Astronomical Society challenges this view, presenting a different perspective. Stars initially fuse hydrogen atoms into helium, which sustains them for most of their existence. Eventually, the hydrogen in their core depletes, leading to the fusion of helium into carbon, although hydrogen fusion can continue in the outer regions of the star. The process then progresses, transforming carbon into neon, sodium, and magnesium in what is known as carbon burning. This process, however, bears no resemblance to the chemical ignition of atoms in oxygen. Supernova explosions occur only after successive rounds of neon, oxygen, and silicon fusion. To estimate the time until Betelgeuse's explosive fate, it is crucial to determine its current stage. Hideyuki Seo of Tohoku University and his co-authors argue that Betelgeuse is not only undergoing carbon burning but is also running out of carbon. Like other stars nearing the end of their lives, Betelgeuse exhibits pulsations, causing it to expand and contract, accompanied by changes in brightness. Astronomers have observed regular cycles of 185, 230, 420, and 2,200 days, along with additional unpredictable variations. The significant dimming of Betelgeuse in 2019-20 was partly attributed to a dust outburst but also involved the coinciding troughs of several pulsation cycles. The central argument in the preprint paper revolves around identifying the radial fundamental mode, RFM, among the pulsation periods. The RFM, whose period is intrinsically related to the star's radius, has been a subject of debate. While others previously believed the 420-day cycle to be the RFM, the authors of the study argue that the 2,200-day cycle holds that distinction. If their interpretation is correct, it implies that Betelgeuse is even larger than previously estimated, potentially reaching a size around 1,300 times the radius of the Sun. Such dimensions for a star of its mass suggest that Betelgeuse is nearing the end of its carbon-burning phase. Once the carbon-burning phase concludes, the star's explosive fate may be only a matter of a few decades away. Although it is challenging to determine precisely how close Betelgeuse is to exhausting its carbon reserves, the fact that it is late in a process that typically lasts a few thousand years indicates that the end is likely imminent. Determining Betelgeuse's exact size has proven to be a challenging task due to significant uncertainties regarding its distance from Earth. The star could be either a very large star located 530 light-years away or an exceptionally gigantic star situated 900 light-years away. Supernovas have the potential to cause significant damage to planets in their galactic neighborhood and have even been proposed as potential causes of past extinction events. However, even at the closest estimated distance, Betelgeuse should be far enough away to pose no threat, while still providing us with a front-row seat to witness what could be the galaxy's first supernova since